Welcome to this video about graphing quadratics in standard form. By the end of this video, you should be able to name basic characteristics and graph a quadratic equation in standard form. So we're going to be using Desmos a lot, so you're going to want to have that available to you either on your phone or switching out from a computer. The first graph, usually when you use Desmos, you don't really want to put the y equals in, so you just want the equation part. So y equals x squared, so you would only enter x squared, like I show right here. So I only have x squared, and this is the graph. So what I want to do to sketch this is I want to get some important points. So here's my vertex, or where the graph turns around. It's at 0, 0. So I'm going to graph 0, 0 on here. And then I'm going to go find some more points. And there's a couple ways we can do this. We can look at the table of values. That's helpful. And it will show us some points, -1, 1. Notice how it's labeling these on here for us. So pause the video and sketch those points on and connect them together smoothly with a U-shaped graph called a parabola. Okay, after you get your points on, it should look approximately like this. And once we've got it sketched, we can go ahead and answer our questions. So for the vertex, remember that's where the graph turns around. That was 0, 0. Our axis of symmetry is the vertical line that cuts through the very center of the parabola. It goes through the vertex. So in this case, it's the same as the y-axis. And the equation of that line is x equals 0. The domain is your left and right. It's your x values for left and right. The graph is never stopping going left, and it's never going to stop going right, so we're going to say it's all real numbers. Our range, it's compared to the vertex. The graph is above the vertex, so our range is going to be greater than the vertex, and it's going to be the same as the y value of the vertex, which is 0, so y is greater than or equal to 0. And this vertex is on the bottom, so it's a minimum, and you can say it's a minimum at 0. It'd be the y value of the vertex. All right. So we've kind of done that before. We're going to add in some real world problems to ask some questions here. So here in number 2, we have a soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. The equation, and they gave us the equation. So that means we're going to use this. You don't change this. We don't have to plug anything in. They gave us the whole equation they want us to use, which gives us the height of the ball after seconds. So our y values are going to be height, okay, and our x values are going to be seconds. So your y value will almost always be height when it comes to our actual problems. So this says the ball was kicked from a ground. So think about it. You had a player. I'm going to draw my little soccer player. He's right here. And he's going to kick the ball. And the ball is going to start here. It's going to go up into the air. And it's going to come down. And it's going to hit the ground. That's our parabola. Okay, so we have a couple questions. We want to know the maximum height. Well, the height is a y value. So your maximum, remember we talked about max and mins here, and it's the y value of the vertex. Same thing. You need to know what is that y value of the vertex. So what we're going to do is we're going to pause and put this equation into Desmos so we can look at it. Okay, so let's go take a look at it. I've got it in here, and depending on how you're scrolled in and out, how much you've zoomed in and out, this is pretty much what you'll look. But we can't see the top, so I'm going to keep zooming out. I'm going to move it around some so I can see the whole graph. Oh, there it is. It goes all the way up to here. So what is this very top spot? That very top spot where it turns around is 2.813. So I'm going to write this and label my vertex. 2.813, comma 126.6. I'll say 126. I'll go ahead and round that. 126.6. Okay. So we got that. So that's our vertex right here. 2.8, comma 126.6. And I just got that from the graph. Now we want to know what is the maximum height of the ball. The height is a y value, so the y value of the vertex is as tall as high into the air that the ball is going to get. So the ball is 126.6, and they said the height was in feet because they say feet per second, so feet is our height unit. So the highest in the air the ball will be is 126.6 feet. Now, there's a question, at what height did the ball start at? Well, it says it started from the ground. So when we look at our graph, I'm going to zoom in so we can see it a little bit better. So in the real world, you can't go over into quadrants 2 and 3. We got to stay in quadrant 1 over here. But the ball is kicked from right here at 0, 0. So I'm going to label that point on my graph. And in fact, while I'm here, I'm going to go ahead and label this other point, this other solution. It's the X-intercept 5.625, 0. These are our most important points. Our Y-intercept, our X-intercepts, and our vertex are the most important. So I've got these labeled and they're going to help me. So what height did the ball start at? Well, we can see here it started right here at 0, 0. You can tell the height that it starts at from the equation. It's going to be the C value. Well, negative 16 is the A value. 90 is the B value. We don't have a C value. That means our C value is 0, which confirms we started at 0 feet because it started from the ground. You're 0 feet off the ground at the ground. Now, how many seconds will it take for the ball to reach the ground? So it's starting at the ground. It's going to go up and it's going to come back down. It's going to hit the ground again. So they're wanting to know, how long did it take to get here? Well, we've already labeled this X-intercept. This X-intercept is 5.625, 0 is the name of the X-intercept. But remember, our X values are in seconds, so that's how long it took. It took 5.625 seconds for the ball to go up and hit the ground again. All right, so that's just the first time we've done that. We'll do a couple of these so you kind of get a feel for it, but let's try another one of these. This is a non-real world example. So you're going to want to pause, put your equation into Desmos, get some of the points to plot onto here, and then connect them together with a smooth parabola, and then come back to answer some questions. So you should have something that looks along this line, these lines. Let me show you. I had to keep putting some more points into my table of values so it would give me some more points to graph. I was getting mainly over here to the right, so I just kept adding more negative numbers so I could get a whole graph here. And so we can see that our vertex is there at -4, -1. Okay, and then I just kept putting in some X values, and if I got a whole Y value out, I would plot that point if I could. Okay, so our vertex here, we already identified it, was at -4, -1. Our axis of symmetry, remember your axis of symmetry goes through the center of the parabola, right through the vertex. And so it will have, it's a vertical line, so it's an X equals line. So it'll be the same as the X value of the vertex, which is -4. Our domain, this is a non-real world problem, so it's never stopping from the left to the right. So we're going to say it's all real numbers. Our range, the whole graph is underneath the vertex because our vertex is a maximum here. So we know it's going to be Y is less than or equal to. And then you need the Y value of the vertex, which is -1. All of the graph is below, equal to or below -1. And then our vertex is on top, which makes it a maximum. So it's a maximum, and again, it's at the highest Y value is -1 because we're talking about the up and down here. All right, hopefully these are getting a little bit easier. Let's try a couple more. So we just were mentioning X-intercepts and Y-intercepts, so here's just a quick review on them. X-intercepts is where the graph crosses or touches the X-axis. They could be called roots, solutions, or zeros. We just did a whole section of the unit on that. We can find this by factoring, by using the quadratic formula. We can tell by looking at the graph, and we can also look at the table of values because the X-intercept is wherever Y equals 0. And for the Y-intercept is where the graph crosses or touches the Y-axis, and this is what we were just talking about. It is the C value when the graph is in standard form. So you can look at the C value of the equation to find the Y-intercept. You can look at the graph to find the Y-intercept, or you could look at the table of values and find where X equals 0, and that will be the Y-intercept. Okay, so we have, we've talked about those a lot, so hopefully that's a quick reminder of what you know about intercepts. Now, we have another real-world problem here. In science class, students were asked to create a container to hold an egg. They would then drop the egg container from a window that is 9 feet above the ground. If the equation of the container's pathway can be modeled by the equation h equals 16t squared plus 9. Okay, so let's pause this and go put that equation into Desmos so we can look at it. All right, so let's take a look. So they're dropping the container out of the window. So here's our y-intercept at 0, 9. And the container is going to fall. They're not actually throwing the container up and then having it come down. They're just holding it out and dropping it. So you'll see it doesn't go up. Our vertex is actually here at 0, 9. So we don't have a grid here, but I'm going to do this and I'm going to label this number 0, 9. And from there, it just fell straight down until it hit the ground. We're staying in the first quadrant here because this is a real world problem. So let's pull that back up and let's get this. This point is 0.750 is the name of that point. There is another point over here. We don't want this point because this is non-real world. If something happens in the real world, we stay in the first quadrant. So we're just naming our stuff here. So our first question, remember your y values are your height. And in this case, our x value, it says, how long will it take to hit the ground? And we don't know if it's distance or time, but it's almost always time. Okay, it would be time or distance there. So what is the maximum height? So if we look at our vertex, 0, 9, here's our vertex. That's the highest the container was, and height is a y value, so the container was 9 feet off the ground when they dropped it. And you can see, look at our c value of our equation, it's 9. The c value is the starting height. So there you go. There's our starting height. Our c value was 9, so the container was never more than 9 feet off the ground. It didn't go up from there. How long will it take the container to reach the ground? We could name our x-intercepts. We don't name this one because this is not real world. We'll stay on this side. So our x-intercept is at 0.750. So if this was time, that would have been probably 0.75 seconds. It's going to drop pretty fast. Okay. If we were talking domain, which this question doesn't ask, remember domain is an x value. This is our domain right here. So it'd be from where x is 0 to where x is 0.75. It's a restricted domain. And then your range is from 0 up here till 9. That's what we talk about when we say it's a little more, it doesn't go on forever and ever in the real world. It's restricted. We'll get more into that as we go forward. All right, I'm going to do one of these. I don't think we need to do both of them. They both are pretty much the same. But let us go ahead and put, let's do number 5. So pause this, put the equation into Desmos, get the graph, get some points, and put it on there, and then we'll go over it. So you can see here, I pulled up the table of values, and I was typing in different numbers to get some points to help me, especially it went off the bottom, and actually we couldn't see the vertex on here, but we can click it, and we get a vertex of 1.5, negative 12.25. So my vertex here is at 1.5 and negative 12.25. The biggest things to make sure you had right was your y-intercept and your x-intercepts. That will help you kind of get the graph on there. So our vertex we got off Desmos. It is 1.5, negative 12.25. Our axis of symmetry. Remember, your axis of symmetry goes right through the vertex. So you want to use the x value of the vertex, which is 1.5. So it's x equals 1.5. Your domain, this is not a real world problem, so your domain is not ending left or right, so it's all real numbers. Your range, the whole graph is above the vertex, so you know your range is going to be a greater than or equal to, and then you need the y value of the vertex, which is negative 12.25. The x-intercepts, you want to name these 2 points. Now, We have them on our graph, but let's look at them here. The x-intercept is where y equals 0. That's why when we solved by factoring, we would set them equal to 0 and solve them. So -2, 0, and 5, 0. So you want to list both of them, -2, 0, and 5, 0. Now our y-intercept we can get either from our equation, 0, -10, or we can look at our graph, and I can scroll it so I can see it, and I can see it's crossing the y-axis right here, 0, -10. Either one of those will work. And then is this a maximum or a minimum? It's the very lowest point, so it's a minimum. It'll be a minimum at, and because the minimum, it's talking about height, really, -12.25. Right, hopefully that was helpful. Let me know if you have any questions, and I'll see you in class.